Alright guys, we're going to go ahead and take a look at one more example of graphing a logarithmic function. Now this one's going to be a little bit trickier because you're going to notice here that we've got x plus 9 in parentheses with this plus 4 outside the parentheses. Alright, so there's going to be some transformations going on here in a little while. But for right now, let's ignore that plus 9 and plus 4. We'll come back to that here in a second. I'm going to go ahead and start this off the same way I did the last example, and that's look at this in terms of an exponential. Okay, so this, if I look at it in terms of an exponential, would be y equals 1/2 raised to the x power. Okay, so this is the exponential I'm going to be working with. And just like I did on the last example, I'm going to start off with a table for this exponential. Okay, so the first thing I'm going to do is create myself a table. I'm going to need some x's. So the x's I'm going to use in this one are going to be -4. Oops, -4. Let's see, we'll also use -3. -2, -1, 0, and 1. Okay. So now that I have some x values, now I'm going to calculate the y values. So if I raise 1/2 to the -4 power, 1/2 raised to the -4 power would equal to 16. 1/2 raised to the -3rd power would be +8. 1/2 raised to the -2 power would be 4. 1/2 raised to the -1 power would be 2. 1/2 raised to the 0 power would be 1. And then finally 1/2 raised to the 1 power, or the first power, would equal 1/2. Alright, so what I've done here is I've created myself a table for the exponential y equals 1/2 x. Now again, just like I did on the last example, we're going to go ahead and swap those x and y's because I want to graph a log, not an exponential. Okay, so I'm going to go ahead and swap that -4 and 16, so that now becomes 16 -4. That next point now becomes 8 -3. -2 +4 now becomes 4 -2. Next point is 2 -1. Next one is 1 0. And that last one is 1/2 1. Okay, so remember, all I did was take this table of values and swap the x and y and the y's, because that's what an inverse is, swapping your x and y's. Now keep in mind that this table represents log 1/2 or base 1/2 x, and that's not what I want to graph. I want to graph log base 1/2 of x plus 9 plus 4. So I have to incorporate these transformations here. Alright, so let's remember, this is our h. This is the one that moves the graph horizontally, left and right. In this particular case, we're going to move left 9. This over here is our vertical shifting. This is going to move up 4. So I've got to move my graph 9 units to the left and 4 units up. Now, there's a couple of different ways that we can do this. Now, since we really don't have a calculator, what we're going to do is we're going to literally take our x and y axis, or our origin, and we're going to shift that around. We're going to move this thing left 9 and up 4. Okay, so I'm going to take my x and y axis and I'm just going to shift it over 9 units to the left, but I'm also going to move it up 4. 1, 2, 3, and 4. Alright, so again, all I've done is taken the x and y axis and shifted over 9 units to the left and 4 units up. Alright, so now we're going to go ahead, and now that we've moved our x and y axis, we're going to go ahead and start plotting these points. Now let's be careful, because when I say 16 -4, we are talking about this x and y axis. So this is our new origin. Alright, so we're going to be moving from this origin right here, not from this one. Okay, so the first thing I'm going to do is find the point 16 -4, and again I'm going to be counting from here, not here. Okay, so we're going to move over 16, and then we're going to go down 4. So that should put me somewhere right about here. Okay, so that's 16 to the right, down 4, because remember, we've moved our origin. All right, next one we have is 8, negative 3. So again, from this origin, we're going to move over 8, and then we're going to go down 3. So that should put me right about here. That's right, 8 down 3. The next one is 4, negative 2. So again, we're going from the origin, so we're going 1, 2, 3, 4, negative 2. Next one we have is 2, negative 1. 2, negative 1 would be right about here. The next point we have is 1, 0. So that would be right here. And the next point I have, or the last one we have, is 1/2, 1. So 1/2, 1 would be right about here. So remember, everything was calculated from this new origin, not from this origin over here. Alright, so now that I've got that taken care of, now I'm going to go ahead and plot these points, or not plot, but connect these points to create my log function. Alright, so this is a little tricky here doing it on the computer, but basically this is what our log is going to look like. So that right there incorporates the moving to the left 9 and up 4. Alright, so now that we got the graph, let's go to our characteristics. So the first characteristic we're looking at is the domain. So the domain for this graph, notice it starts over here at negative 9, because that's where we move the y-axis, and then it continues to move to the right. So our domain for this one would be negative 9 to infinity, positive infinity, going all the way to the right. The range, or the y values, is still negative infinity to positive infinity, because this graph continues to go up, and it also continues to go down forever and ever and ever. So that's why our range is still negative infinity to positive infinity. Now let's look at the end behavior. So first of all, if I move towards the right, okay, notice that we're starting at negative 9, because that's where I moved my graph. I moved it over 9 units to the left, so we're starting at negative 9. And it's going to continue to move to the right towards positive infinity. So the end behavior as x approaches negative 9, and we go towards positive infinity. Alright, so what we're saying here again is as x approaches negative 9, so we're coming this direction here, as we're approaching negative 9, the y values are approaching positive infinity. It's going up. So we're going from this direction over to this direction here. Alright, the next end behavior we're going to look at is as x approaches positive infinity. So now as we move to the right, notice that the y values are going down. They're decreasing. So we're going from positive infinity. As we move to the right, the y values are going down. So we're going towards negative infinity. Alright, next thing they're asking for is the x-intercepts. The x-intercept, remember this is the x-axis. The x-intercept is this point right here, and that point is 7, 0. And the last thing we need is that asymptote. Remember, we shifted everything over. So the asymptote is this line right over here, which is x equals negative 9. Okay, so it's very similar to what we did on the last example. The only thing you're really going to have to be careful with here, guys, is this transformation. Here we had to move left 9 and up 4. So all I did was shift my x and my y-axis over 9 to the left and up 4. From there, we'll use this new origin to plot our points. Alright, good luck. Give it a try. Got any questions? Leave me a comment in Google Classroom, and we'll get back to you as soon as possible.